Good afternoon, Dr. Metawala. My name is Josh Hersey, and this is my Stoichiometry Procedure Lab. Now, the purpose of this lab is to observe and identify types of chemical reactions, to determine a limiting reactant and how it will affect the amount of product formed, and to calculate percent yield of a reaction. So with that being said, here are the materials that I have for this lab. I have my various pieces of aluminum foil, and I have extra aluminum foil if needed. Now this aluminum foil will be used as a sort of buffer between my chemicals and my scale, which I will be using to measure out specific masses of my chemicals. Now the chemicals I have cupric sulfate in the solid form. I have cupric chloride in the solid form. I have ammonium chloride in the solid form. I have ammonium hydroxide in the 7.5 molarity. And I have hydrochloric acid in the 6.0 molarity. I also have various test tubes, you can see right here, in a test tube rack that I'll be using once I prepare my chemicals. I will be labeling the test tubes and storing them properly on my test tube rack. I also have various beaker sizes to help measure out my liquid chemicals. I also have filtered paper and my distilled water. So without further ado, let's get started. Alright, so at this point in my lab, before we actually perform any of the chemical reactions, I need to properly prepare the chemicals for the reactions. So for my first reaction, it is between a 0.5 molarity of cupric sulfate and a 1.0 molarity of sodium carbonate. So I'm going to begin by preparing my 0.5 molarity of cupric sulfate, and by doing that, I will be measuring out 0.8 grams of cupric sulfate, which I'm not sure if you can really tell from this video, but I already have that measured out on the scale. And from there, I will be pouring the cupric sulfate into my labeled test tube here. If you can read it, but it says CuSO4. That's how I'm going to be labeling my cupric sulfate for my lab. And then from there, once I get it into my test tube, I'll be using 10 milliliters of distilled water, which I already also have measured out. So I'll be pouring that into the test tube and then using my stirring rod to properly dissolve the CuSO4. And once it is fully dissolved, I will be storing it properly until it is time for the reaction. So I'm going to fast forward while I get all of this done, or not all of this done, while I get my cupric sulfate prepared, and I'll be back in a minute. So while it's not 100% dissolved yet, this is what it looks like while dissolved. As you can see, the water's just got a bluish color on it. And now I will store this. Hello, welcome back. So now we're doing part 2 of our first reaction, which is preparing our sodium carbonates, which we have right here. So basically, before I go into fast forward mode, I don't even think you can see. There we go, that's better. So what I'm going to be doing is basically the same thing as last time, except this time I'm going to be measuring out 1.51 grams of sodium carbonate instead of 0.8. So I'm going to do that, and then basically the same thing. I have a beaker this time, because I mean, as you can tell in the last video, we had a little trouble stirring in the small test tube. This is not the same beaker I used in the last video. That one is off to the side and cleaned out. So what I'm going to be doing is pouring once I get my 1.51 grams, I'm going to be pouring it into that beaker. And then from there, I'm going to be doing the same thing, pouring my 10 milliliters of distilled water into the beaker, and then stirring until completely dissolved, and then placing in my labeled test tube, which is, as you can see, is Na2CO3, which is the chemical formula for sodium carbonate. So now I'm going to fast forward, and I'll be back once I get prepared. video. Just wanted to give you a quick look at my Na2CO3. As you can tell, I mean, not a lot changed. I mean, the water did turn white just off physical appearance, but yeah. So I'm going to properly store that with some aluminum foil, and I'll be back for my next preparation. Alright, so for the next part of my lab, we are doing the second chemical reaction, or preparing for the second chemical reaction, that is, which is 6 molarity of HCl combined with 7.5 molarity of NH4OH. So for the first part of this lab, we are going to be preparing our HCl, which is actually right here, hydrochloric acid. For this one, we are going to be taking 5 milliliters of hydrochloric acid, which has already been measured out in our graduated cylinder here. We're going to be taking it and pouring it into our test tube, and then after we pour it in there, we're going to be taking 5 milliliters of distilled water, which is measured out in our beaker right here, and we're going to be pouring it into this test tube, which is labeled HCl. And then just like the other two, we're going to be stirring until completely dissolved. So I'm going to leave and fast forward. Here we go, the dissolved hydrochloric acid and distilled water. I mean, you can't really, obviously with it being a liquid, you're not really gonna see that much of a difference. But alright, so now I'm back for the second part of my second reaction, which is preparing my 10.0 milliliters of 7.5 molarity NH4OH. As you can see right there, the ammonium hydroxide. Also, I don't know if I mentioned in the last one, but I did store my HCl properly. I sealed it with aluminum foil, and I have been for the last 3. So I apologize if I haven't been forgetting to show those. But so for this next one, we have the ammonium hydroxide. We have essentially the same thing as our last one. We have 5 milliliters of ammonium hydroxide here in this beaker, and 5 milliliters of, I don't think you can tell, distilled water. I'm going to start off by pouring the ammonium hydroxide in the beaker, and then followed by the distilled water, is the same as last time. And then I'm going to stir until the ammonium hydroxide is completely dissolved. So here is the dissolved ammonium hydroxide in the distilled water. I'm going to go ahead and seal this bad boy up with my aluminum foil. And bang! That is, and now I will be back for the next part of my preparation. Alright, so back again. This time doing preparing the fourth and final reaction. If you're wondering why there is no video for the third reaction, that is because for the third reaction I need to use some of my HCl from my second reaction. So since that's already been prepared, I don't really need to prepare it again if I'm just using some leftovers. And then I also need to use, if I can pick it up, oh, I just dropped it. But anyways, it's a 2x2 piece of aluminum foil that I had prepared from my introductory video. So if you're wondering why there is no video for part 3, that is why the preparations have already been prepared, so to speak. And so, excuse me just for a second while I grab some more aluminum foil. So prepared for my fourth and final reaction. Once again, if I can pick it up, there's another piece of 2x2 aluminum foil down here. Can't pick it up, but it's right behind this one right here, if you can see that in the video. I can actually just pick it up and show you. It's right there. But so that's my aluminum foil, and then also got our CuClO3 in the solid form. For this experiment, we're going to be measuring out 3 grams of this on the scale. We're going to be pouring it into this beaker right here, which has already been tared out and zeroed. So I'm going to be pouring 3 grams into that. And once I get that, I'm going to use my 20 milliliters of distilled water. I'm gonna pour that into my beaker after I get my 3 grams. And just like last couple of times, I'm gonna be using my stirring rod to fully dissolve. And I have a spoon here, gonna help me scoop out some of my chemical so that I can get an easier transition from the bag to the beaker. I'm not sure why I didn't think about this until, so we could use this for the first reaction, but now we're using it now. So I'm gonna measure out 3 grams here. Alright, welcome back. So now we are actually starting on our actual reactions. So we're going to start off with our first reaction, which is our 1.0 molarity of sodium carbonate and our 0.5 molarity of cupric sulfates. So for this reaction, excuse me, I'm just kind of reading off this as I go, but we're going to start off by measuring out our 3 milliliters of our cupric sulfate into a test tube, which I've actually already done here, just to go ahead and save some time. So I've had that measured out. And then once I measure this out, once I get going into the actual reaction, I'm going to use that. My reset right there. I'm going to go ahead and reset that and mass it using this. I'm going to go ahead and use this beaker for stabilization of the test tube. And I've already massed the beaker. The mass of the beaker it's been tared, so just have that there just to help kind of balance the test tube on the beaker. So once I get the mass of the cupric sulfate, I'm going to record it here on my notebook. And then I'm going to do the same exact, literally the same exact thing afterwards with my sodium carbonate, which I also have measured out in a 3 milliliter test tube. I'm going to get the mass of that and the same thing and record it. Once I get the mass of both of them before, I'm going to then combine the sodium carbonate. I'm going to pour that into the cupric sulfate test tube. And then I'm just going to wait, let the reaction occur. Once I give a minute to the reaction occur and give out some observations that I'm recording that I see from the reaction occurring, I'm then going to use my filter paper, which I already have folded up into a funnel, to sort of separate the solid product from the aqueous products. And then I'm going to do just the same thing I did at the beginning. I'm going to take the mass of the solid product and record it on my notebook. I'm going to take the mass of the aqueous product and record it. Oh, and I also forgot to mention that I'm going to mask the results once the reaction occurs and record that as well. And then, yeah, so I'm going to go ahead and just fast forward while I'm taking the mass. And I'm going to go ahead and angle the camera a little differently so you can see the mass a little better. And let's go ahead and get started. So I went ahead and took the, just took the mass of the cupric sulfates. And I forgot to mention before I started, I got the mass of an empty test tube. I set it off to the side. It's the same exact test tube, same size, same everything. And its mass was 19 grams. So from that, I can now see that the mass with the cupric sulfate in the test tube is 22.65. So using my calculator, just do 22.65 minus 19. And I find out that the cupric sulfate has a mass of 3.65 grams, which I'm going to record here. And I do the same thing with the sodium carbonate. This mass is 22.84, so 22.84 minus 19, 3.84. That, I mean, you can kind of tell from this, I mean, the reaction, I mean, it may take a minute or two, but if you can see here, it's kind of puffed up a little bit. As you can tell, it's a little cloudy, it's very cloudy. It's kind of just a white and a blue combination so far. Just extremely combination appearance. Cloudy, light blue. It appears to be a lot thicker than what it was. I mean, you can still tell, especially at the top up here, it's a little bit of water still, but everything more towards the middle and the bottom seems to be a lot thicker. So, you can tell, I mean, it kind of look, just off appearance, I can see, it seems to guess that energy was absorbed, but I have a thermometer here so I can check temperature. If the temperature increases, then we got endothermic. If not, then exothermic. So we got ourselves an endothermic reaction. So now I'm going to do the same thing, like I said. I'm gonna take the mass of that. I'm gonna go ahead and place my beaker on first. Let's just, I think it's a, tear that. We got a mass of the product of 26.05. So if I do 26.05 minus 19, we have a mass of 7.05, which obviously, I mean, if you take the adding together, it's not really so much of a surprise. Now, take this off. I'm actually gonna use this beaker to filter out my product. Set up like so. So if you can see there, just poured my liquid into my filter paper. Gonna let that go through. With the beaker. The mass of the beaker, before we go ahead and get going, is 100.65 grams. So using that, my liquid is 102.31 minus 100.65, 1.66 grams. And that's my first reaction. We'll be back for the second one. All right, so I am back for my second reaction. This is the part 2 reaction in my lab design. We're still on part 5, and this is going to be, more specifically, this is going to be parts B of part 5 in my lab design notebook. So you can see right here, part B. So what I'm going to do, I started off by measuring 2 milliliters, this reaction is, first off, 6.0 molarity of hydrochloric acid with 7.5 molarity of ammonium hydroxide. Sorry, I forgot to mention that. But I started off by getting 2 milliliters of the hydrochloric acid, went ahead and measured it out to save time. What I'm going to do is I am going to leave that right there for now, and I'm going to take my NH4OH. I went ahead and took the safety seal off of that, not the safety seal, the precaution seal off of it, excuse me, so because I'm going to be using it. What I'm going to do is I'm going to be sticking a glass rod with filter paper on the end of it. On the online it says use a rubber band, but I do not have a rubber band in my premises, so I used a very small piece of tape to tape the end of the filter paper to the glass rod, and I'm going to stick this into the NH4OH, kind of wet up the filter paper, so to speak, and I'm going to take that and stick it in the NOH, just kind of hover it above the HCl, and just record and talk about the observations as it goes on. So I'm going to go ahead and do that. Tell from the video, but it appears that a little bit of solid is starting to form at the bottom of HCl. I'm not sure if that's what's supposed to happen, but appears something's starting to react down there. Not a lot physically is changing besides the fact of that, but appears that since that's forming, it appears it's going to be an exothermic reaction type. Energy is being released is what it looks like. And since a solid is forming, I feel like it's either a precipitate or a neutralization reaction, but just based off the fact that we're doing hydrochloric acid and ammonium hydroxide, it's more than likely going to be, looks like NaCl is probably what's going to end up forming. So if that's what it is, then it's going to be a neutralization reaction or acid base, because salt and water are going to form from that. So yeah, so my initial reactions from that, I'm going to take that out, And yeah, I'll be back for reaction 3. All right, so I am back for my part 3 reaction. This is the reaction I didn't really need much of a setup for, or preparation kind of. Just need to get my aluminum foil and my hydrochloric acid, excuse me. So for starters, what I did, just to go ahead and prepare, just to save some time, I went ahead and crumbled up a 2x2 piece of aluminum foil, just to show you. Here's another one. That's the size it was. I crumbled it up, and then I placed it in this test tube here, which is on a metal rod. So I'm not really sure if you can tell in the video, but there is a crumbled up piece of aluminum foil on the bottom there. Excuse me. And then from there, I did the HCl that I used in my, not the same HCl, but the HCl that I already prepared. I got 2 more milliliters from that, just poured into the test tube. And what I'm going to do is I am going to pour this HCl carefully into here and just watch the reaction and record any observations. So this, I was given a forewarning that this reaction may take a minute just to kind of get started. So I'm just going to go ahead and fast forward until the reaction starts. Did take a minute to get going, but actually it's not fully complete yet, so to speak, but it's getting going right now. I'm not sure if you can tell from the video, but you can see the glass is starting to fog up. The aluminum foil is starting to bubble in the HCl as we speak right now. You can hear the bubble. You can actually hear the bubbling. I'm gonna be quiet for a sec, see if you can hear it. And now we're really getting going. Open this door. Ventilation. Oh yeah, there we go. So, now that the reaction is completely done, I mean, you can see, obviously, there's a color change going on. Water went from clear to gray, and the gray aluminum foil kind of combined, so the water is completely gray right now. I mean, as you can tell, I'm not sure if you can see from the bubbles or not, but it's clearly an exothermic reaction. And since the energy was released, it looks like, just based off the fact that it's going to be aluminum foil with HCl, I mean, we can kind of tell that the hydrogen ions from the HCl, they would get moved over to the aluminum, which would then make this a redox reaction, or oxidation reaction. And I mean, it looks like there might be some sort of solid or something kind of towards the bottom of the beaker, but I can't really hear. I'm gonna move the video closer so you can get a good look at it. But yeah. So, I mean, that was so far probably that's all we got, and I'll be back for part 4. Alright, so welcome back. This is my 4th reaction. This is the aluminum foil with the copper chloride. So for starters for this reaction, I get my 2nd piece of 2x2 centimeter of aluminum foil. I'm going to crumble it up and place into a beaker. Now on the directions, it says use a 100 milliliter beaker, but I use my 100 milliliter beaker to store my copper chloride, as you can see right here. So what I'm going to be using for this reaction is a 250 milliliter beaker, which I know is a little bigger, but that's what we're working with. So start by placing my aluminum foil, crumble it up a little bit, and place it in my beaker. And then what I'm going to do, I'm going to get my other glove on. I'm going to use my syringe and get 20 milliliters of this. That's all 20 milliliters, but I'm going to get my 20 milliliters here and pour it in here. And we're going to watch as the reaction consumes. The aluminum foil is actually it's completely changing color. I'm not sure if you can really tell. I'm gonna try to wait a little bit to let the reaction fully complete. But it's a completely different color, as you can tell. Actually, I don't think you can. Where'd it go? Oh yeah, you can see it's in the bag right there. But it's kind of a brownish, kind of rustic now. It's actually just like, even like if it moves at all, it's kind of falling apart. Like I said, it's kind of a rustic color. Obviously it's a completely different substance now. I would say that this looks like it, obviously, I mean, with that changing, the energy is being released. That's obviously an exothermic reaction. Just based off the chemical formula, this is easily a single replacement reaction, just based off the formula. But based off like looking and seeing the reaction, I would say this is kind of probably a oxidation or a redox reaction as well. But so yeah, I mean, obviously a new substance was formed, and that's my reaction. Hey, Dr. Metawalla, this is Josh Hersey back with my analysis. As you can see, I've got it all written down. And so basically what I'm going to be doing is just kind of going over my analysis, what I wrote for my analysis. So the analysis for this lab was in two parts, part A and part B. So for part A of the lab was basically just kind of going over my reaction, going over my reactions and giving thoughts for each reaction, like the initial appearance of my reactants, any qualitative observations from the reaction, the physical appearance of the products as the reaction was occurring, writing down the chemical equation, which I have written down and I'll read it out to you when I get there. Identify each type of reaction, so like redox, precipitate reaction, or acid-base reaction. And then finally, I was identifying whether the reactions were endothermic or exothermic. So like I said, I'm just going to be reading off what I wrote down, and I'll be adding these pages to the end of my video. So for starters, for the first reaction, which was the cupric sulfates and the sodium carbonates, I wrote that the initial appearance of the first reaction was that the CuSO4, the cupric sulfate, was a sort of bluish liquid, and the Na2SO3, which was the sodium carbonate, it was sort of a white liquid, and it appeared a lot, I don't even know, silky, more silkier than the CuSO4. So the resulting product from this reaction, it was sort of bluish white in color, and the test tube appeared a lot more cloudy. So there's no really noticeable smell or any sort of noise coming off from the reaction. And I wrote that this reaction was a precipitate reaction because a solid and a soluble liquid were formed from this, and it was an endothermic reaction. So, and I also wrote that the balance equation for this, I don't know if you can see from this video, but I wrote that it was CuSO4 in the aqueous form plus Na2CO3 in the aqueous form yields CuCO3 in the solid form and Na2SO4 in the aqueous form. So for my second reaction, which was the NH4OH, or ammonium hydroxide, and the HCl, or hydrochloric acid, those combination. So the initial appearance of this reaction was that both liquids were extremely clear liquid. I mean, you can really, if you were to put one next to it in water, I wouldn't really be able to see a extremely noticeable difference, except that the ammonium hydroxide just appeared more dense from basic observation. So once the reaction occurred, the product was still clear, but it appeared to have formed some H2O in another sort of liquid, so to speak. And there wasn't really a noticeable sound or a smell from the product. The ammonium hydroxide sort of had a stronger smell to begin with, but once the reaction occurred, it wasn't really as noticeable of a smell. I wrote that this reaction was a combination reaction. It was an example of a neutralization reaction as well, and I wrote that it was exothermic. So the balance formula for this equation, if you can see, was NH4OH in the liquid form plus HCl in the aqueous form yields NH4Cl in the aqueous form and H2O. So for my third reaction was the aluminum foil, a 2x2 centimeter piece of aluminum foil, and some HCl that was also used to prepare in the second reaction. So for my initial appearances for this reaction, it was sort of the same as reaction 2. The HCl was very clear, obviously, because it was the same HCl that was used to be in preparation for lab 2. And I mean, it was just basic aluminum foil that I was used to. It was a very small piece, and I mean, aluminum foil is shiny, so this one was no different. It was shiny as well. And once the reaction occurred, the resulting product that was formed was extremely, like once the reaction was occurring, it was extremely bubbly and sort of smoky out of the test tube. the bubbling progressively got louder. I mean, I'm pretty sure you could tell from the video, but there was a noticeable sound of the bubbling once the reaction was occurring. And there was a slight smell. It wasn't anything in particularly strong, but there was a slight smell, and the product was a dark gray liquid in color. I said this was a redox reaction because the reactants, the HCl and the aluminum, the hydroxide ions were getting transitioned from the HCl to the hydrogen, which was in one of the products. Excuse me, I couldn't think of the word for a second there. So I also said this was exothermic because, I mean, you could obviously tell from the reaction occurring itself, a lot of energy was being released during this reaction. And the balanced chemical equation I put for this one was 2Al in the solid state plus 6HCl in the aqueous state yields 2AlCl3 in the aqueous state and 3H2 in the gaseous state. So finally, for my fourth reaction, which was copper chloride reacting with another piece of 2x2 aluminum foil. So obviously aluminum foil is the same thing as the third reaction, as at least the initial appearance was. For the CuCl2, it was a liquid. It was a lot more clear than some of the other liquids that we've been working with, especially the liquids in the first reaction, and it was blue in color. So once while the reaction was occurring, the aluminum foil began bubbling while it was reacting with the CuCl2, and it began changing substance. There wasn't really a noticeable smell or anything from this reaction. There was a little bit of sound from the aluminum foil bubbling, but other than that, that was pretty much it. And once the reaction finally occurred, the product was a brown, almost rustic-looking substance, which makes sense because copper ended up being formed from the substance. And there was still some liquid in the reaction. It was still blue, so some AlCO3, excuse me. This reaction, I said, was another example of a redox reaction this was also an exothermic energy being released reaction. And the chemical reaction for this equation was 2Al, in the solid state plus 3 CuCl2 in the aqueous state yields 3 Cu in the solid state plus 2 AlCl3 in the aqueous states. Now, for the second part of this, of my analysis, was just some example to go over the limiting reactant for the first reaction, and then once I figured out what the limiting reactant was, I was to show my calculations for the limiting reactant, show the percent yield and the theoretical yield for that reaction as well, which I will have included in my lab notebook at the end of this video. And once I did that, there was also a problem about just a lab group who formed some copper in their reaction, and I'm supposed to find the percent yield of the copper that they got in their reaction. So I'll explain how I got my answers for each problem, but I will have my work and calculations in the lab notebook at the end. So for the first part of part B, I said that the excess reactant for the reaction was the sodium carbonate, and the limiting reactant was the cupric sulfates. Once again, the excess reactant was the sodium carbonate, or Na2CO3, and the limiting reactant was the cupric sulfate, or CuSO4. And the evidence I used to support this was that when you watch the reaction, it appears that less of the CuSO4 was used to produce the product. So, I mean, just basically off visualization, you can kind of tell that the CuSO4 was the limiting reactant. And another piece of evidence is when you're doing the calculations to into moles to figure out the limiting reactant, and you can see that there's less moles of CuSO4, which signifies that that is the limiting reactant. So, the calculations I used to see that was, you can see from this, I started off with grams of CuSO4 and grams of Cl2, and using their molar masses, I converted both into moles, and I got 0.005 moles of CuSO4 and 0.014 moles of Na2O3. And so from those calculations, you can see that since there are less moles, then CuSO4 is the limiting reactant. And then after that, I did, using my products and the masses that I recorded in my experimental design, I used those to figure out both the theoretical and percent yield for both the CuCO3, the NaSO4, and the combined total mass of both of the products. And I got that the theoretical yield for CuCO3 was 6.18 grams, and the theoretical yield for Na2SO4 was 1.98 grams, and the combined theoretical yield was 8.16 grams. And then from the third problem, I started off by writing out the balanced chemical equation for the product that the students used, and I got 2Al plus 3 CuCl2 yields 3 Cu plus 2 AlCl3. And once I got the balanced chemical equation, I converted grams of the 0.5 grams of aluminum that they started off with all the way to grams of copper, and I got that the theoretical yield for copper in their equation was supposed to be 1.76 grams of copper, but the actual yield was 1.5 grams. So from there, I just calculated the percent yield, 1.5 divided by 1.76, and got that their percent yield was 85.2%. So once again, thank you for your time and watching my video log, and I'll have my lab notebook pages posted at the end of this video or on a separate Word document PDF, and see you in the next lab.